If you could reduce JavaScript bundle size by adding just one config option, you would, wouldn't you? But is it really ever that easy? Or worth it? Well, let's find out. Welcome to the second episode of Hellbent for Webperf, where I, Jeremy Wagner, talk about tips, tricks, tools, and APIs that can help you make your websites faster. In this episode, we're going to cover a very specific Webperf tip that could be a potential quick win, which may lower the size of your JavaScript bundles in certain situations. That quick win is the loose mode config option in Babel preset-env. Now let's step back for a second in case that last sentence made no sense to you. In today's JavaScript development ecosystem, we rely still quite a bit on a tool called Babel. Babel is there to transform the JavaScript we write into a form that can work in all the browsers it needs to. We often use it for compatibility, but we also use it to transform syntaxes that aren't JavaScript, such as JSX. If you're using JSX, chances are very high that you're using Babel to transform it. Now here's the deal with Babel. Depending on what JavaScript you write, and even sometimes how you write it, as well as the browsers you're transforming your JavaScript for, Babel will sprinkle in things called transforms and helpers to make sure newer language features work everywhere you need them to by transforming them to ES5. Here you can see we have an example function on the left. On line 1, you can see that I'm using what are called default parameters in the function signature, which are used when an argument isn't specified. On lines 3 through 5, you can see that I'm using shorthand property names. You may have seen features like these in other languages, but in JavaScript, they're relatively new. Depending on your defined targets in Babel, they may be replaced with code like what you see on the right in order for them to work in all the environments you'd want them to work in. By now, you want me to get to the point, so here it is. JavaScript features are defined in specifications which are a part of the standardization process, and while the way specifications are written is arguably intended more for implementers than developers, the behaviors they define are strict for a good reason. Except when it comes to how Babel transforms those features into more compatible forms, strictly adhering to the specification can lead to excess JavaScript being sent to the client when a smaller and less strict version may run just as fine. So finally, this is where Babel preset-env's loose mode comes in. Loose mode is Babel's way of saying, hey, maybe you don't need all of that transform code to behave exactly the way a specification says it should. Chances are, your transform code may work fine if it were, well, a little loosey-goosey. So that, in itself, is an opportunity to ship less code. So let's see how that might work out. Here's a trivial example I've put together to show you how loose mode works, and if you want, you can check out this code for yourself at the URL below. The code in this project is an admittedly contrived example of an ES6 class for a car with a constructor that takes parameters for the make, model, and year of the car. But the example itself isn't so much the point as what Babel does with this code. This code is processed by a bundler, Rollup in this case, which builds two different versions of the code that are transformed by Babel, both of which are processed by Babel preset-env. The first config generates a version of the code that doesn't use loose mode, so the generated code adheres strictly to the ECMAScript specification. The second config generates a version that enables loose mode, which you can see right here on line 33, is turned on in Babel preset-env through the loose option. So let's take a look at the outputs from the bundler. Here's the strictly transformed version of the code. As you can see, there are functions at the top, what Babel calls helpers, that ensure the way that the ES6 class is transformed works exactly as ES6 classes are specified to work. For example, you see this function at the top called class call check, which ensures that when an object is instantiated from a class, that the object is an instance of that class. Plus, there's a few other methods that enforce other behaviors to ensure ES6 classes work the way they're specified to in environments that don't support them. Now here's that same class but transformed in loose mode. It doesn't have any of the helpers that you saw in the strictly transformed version, and as a result, it's much smaller. Sure, it doesn't adhere to how ES6 classes are specified to work, but if you recall what it was like to write classes before ES6 classes were a thing, this is very much the same approach. So, you can see how loose mode could help to reduce bundle size, but really just how much are we talking about here? Well, that depends on two things: the features you use in your code, and then the browsers you've configured Babel to transform code for. So, in the example I showed, we have a browsers list query set up to target 95% of browsers in global use currently. That means we're accommodating a lot of people out there that can't use modern ES6 features for whatever reason. So if you're lucky enough to have an audience that uses modern browsers, which supports most ES6 features natively, then you may not see much of a benefit from loosely transformed code. But then again, it just depends. So for example, it can be a completely valid need to support IE11 and pre-Chromium versions of Edge, or browsers on platforms that no longer receive updates. It's inconvenient, yes, but some apps have these requirements and they are non-negotiable for now. Still, loose mode can provide at least a marginal benefit, even for code that's generated specifically for modern browsers. Here, I'm in a project folder for an app I've written to showcase the CSS Paint API, which, if you do want to check this out, the link is at the bottom of the screen. Now, even though that API doesn't work in older browsers, I needed to generate a version of my app's code that would work in older browsers just well enough to let users know that the Paint API isn't supported in their browser. So, let's take a look at the bundle sizes for this app. 2 bundles are generated for the app, and we use the module no module pattern to serve a bundle with more transforms to older browsers that need them, and a separate bundle with less transforms to newer browsers. Now, I really don't want to get in the weeds about this process. I will get to it in another episode sometime, but we are talking loose mode here, so let's kind of keep the focus there. So let's take a look at the size of the bundles on the disk. So these bundles are generated without using loose mode. The bundle for modern browsers, this is the one with the .mjs extension, is about 16.7 kilobytes. The other, meant for older browsers, is about 19.6 kilobytes. Now, let's see how these bundles benefit from loose mode. Before we rebuild the project, we'll need to enable loose mode for both bundles, which can be done, as we said before, by enabling the loose config option in each configuration. So, let's do that. Now, let's rebuild. Now we can see that the bundle for modern browsers is reduced by about 3.5%, and the one for legacy browsers is reduced by almost 11%. In both cases, the code still works as expected. So you might be thinking, well, what the hell's the big deal about a few kilobytes here or there? And my answer to that is, depending on your application, the gains could be more than that, or maybe less. But the thing is, it's a one-line change in your Babel configuration. One line. It takes you a minute to try it out to see if it makes a difference for you. And isn't that worth 1 minute? But I don't want to give you the impression that loose mode is just something that you can turn on that's going to be foolproof in every case. It does depend on, well, a lot of things. Enabling loose mode may backfire on you in some cases. In this article by Dr. Axel Rauschmeier, he notes that, and I quote, "You risk getting problems later on when you switch from transpiled ES6 to native ES6. That is rarely a risk worth taking." I will readily admit that Dr. Rauschmeier is far more qualified in this field than I am to make this pronouncement, but I do disagree, at least in part, because it always depends on the context. For example, if your project uses JSX, which is a feature that isn't supported natively in any browser, you're never likely to remove Babel from your toolchain unless JSX becomes part of ECMAScript, which may never happen. But he does have a point. Depending on your project, you may end up with some issues if you do switch to native ES6. But if you could realize a decrease in bundle size today and end up with issues when you go to native ES6 down the road, you can always address that tech debt when the time comes. And to be fair, you should always be doing some amount of regression testing to ensure any code change doesn't break your app for users, let alone config changes in your build tool chain. So, my recommendation? Just give it a shot. See how it works for you, and as always, test, test, test. And with that, let's switch gears over to this episode's community showcase. In this episode's community showcase, the focus is on Estelle Weil. Estelle's accomplishments and contributions to the community are far beyond just web performance. Estelle is a top-shelf web developer who writes performant code, and she teaches what she knows. She is a prolific author who has written and contributed to numerous books, including the 4th edition of CSS The Definitive Guide, and is responsible for writing and organizing the lion's share of web performance-related content you find on the Mozilla Developer Network, better known as MDN. Chances are you've learned a lot from what Estelle has written, and you didn't even know it. In recent years, she's also been the organizer of Perf Matters Conference, a developer conference that focuses on front-end web performance and has made inclusivity a priority by elevating women and underrepresented people in tech to talk about their work in web performance. The 3rd edition of this conference wrapped up very recently in an online-only format that was both fun and informative. I've been lucky enough to be in attendance for all editions of this event, and I can't recommend it enough for those who care about making the web faster for everyone, everywhere. So check it out. And that wraps up this episode of Hellbent for Webperf. I hope you liked it, and if you did, consider subscribing and following the show on Twitter at Hell4Perf or me personally at Malcata. I'm looking forward to seeing you all again real soon. Take care.